Okay, I'm going to assume you've already read and looked at the video for this on problem 1, so I'm going to move a little bit quickly through problem 2 because it's close to the same with just really one slight change that will have some other implications, but population means same hypotheses. Null is that we're equal to 16.2. Research that we're not equal to 16.2. We're still going to reject HO. P-value is less than 0.05. Again, nothing's changed there. Now here is what's changed. If you have sample standard deviation, and you could see that, I had bold-faced that in the problem. A, you'll have t-test instead of z-test, and you'll use the sample standard deviation in your formula. Now numerically, in this case, since I used the same numbers, still going to come up to be 2.27, but it will actually come out to a different p-value because what we have is a little bit an added piece of uncertainty, because when we calculate the sample standard deviation, it's not the population standard deviation. We're just basing this on sampling other than something that we have from the population. To get the p-value now, we're going to have to use technology of some sort, either a computer or a statistical calculator. The other thing you need to know about the t, so we've had that it's a t-test because we have sample standard deviation, and that's exactly how you know you have a t-test, is if you have sample standard deviation either computed for you as it is in this problem, or a sample standard deviation that you have to compute yourself. Now, hopefully you have the t-table with you already, and if you don't, you should probably get that out. Although we're going to do this with a calculator right now, it'll be useful for you to have that table in a minute. One part of that table and one part of something that you need to be concerned with any t-test is something called DF, or degrees of freedom. There is a point in this course when it'll make sense for me to explain degrees of freedom. For right now, let's just know that for a one sample t-test, we'll have n-1 degrees of freedom. Since our sample size in this problem is 25, we'll subtract 1 and have 24 degrees of freedom. We'll need that whether or not we use a calculator or a statistical table. We'll not always want a calculator. You'll see that in a little while. So here's how to get a p-value using your calculator. This is a TI-83 or 84 calculator. You'll need to go to second VARS. It's sort of maybe, if I remember right, the second or third row down and over towards the right a little bit. And what you're really trying to do is get to the DIST, or distribution function, and that you can get there by doing second VRAS. Then you'll select the option that says TCDF, and then that'll bring up a line that just has TCDF in an open parenthesis. What you have to enter is the lower limit for what you're looking at, the upper limit, and the degrees of freedom. Of course, that degrees of freedom in this case is going to be 24. The lower is going to be 2.27 because we're going from 2.27 standard errors and up. And the upper limit really is at infinity, but if you just pick any big number, that's going to be far enough that you're going to be either really, really close. I usually pick a number of 100, but any big number will do on that. Again, that's just what I just said. Just writing it down separately there. Here we go. This is what we will